Okay, welcome to the second example. So we're going to answer the second one now. What we're trying to find this time is the length from there to there. I mean, what must the length x be for this wrench? Okay. Now, what the question says is we're actually going to apply a force that is in the vertical direction. Okay, it's perpendicular to the ground. So the line of action of force is straight down. Now, what's the perpendicular distance? Well, it's going to be this distance here, the yellow line. Okay, so what we might do is just calculate that first, because we know what the force is. Okay, we're going to find D, that perpendicular distance, and we know the torque. Okay, sorry, the moment. So the moment is equal to FD, and moment is 190. The force is 250 from the first question, and we're going to solve for D. So D is equal to 0.76 meters. Now, that is not the answer, because the answer is actually what is the length of the wrench. What we have just calculated is the perpendicular distance. Okay, so that's not really what our answer is about yet. So what we're going to do is use this value, and let's draw a little triangle. So at the moment we've got the length of this side is 0.76 meters. We've got an angle of 15 degrees, and we're trying to find in the end that length there, which is the length of the wrench. So it's just a bit of trigonometry. And I'll leave that to you. Okay, so the next part here, equilibrium again. Okay, we know that the algebraic sum of all forces must equal 0, but what about the situation below? Are they in equilibrium, and do the algebraic sum of the forces equal 0? So in this case, yes, force 1 there, let's make it a positive 10 newtons, make this one a negative 10 newtons. Do they add up? Do these things add to 0? Yes, they do. Okay, so we can say that that one, the algebraic sum of the forces equals 0. This one here, positive 10. This one, negative 10. Algebraic sum equals 0. Good. But is it in equilibrium? Okay, can you imagine if this was lying on a frictionless surface and you pushed them in the two corners like that, what would happen? Hopefully, you're going to say that the object is going to rotate around like this. Okay? It's actually going to rotate in a circle. So is it in equilibrium? No. And in fact, it's actually going to keep accelerating around in circles. So is it in equilibrium? No. So that means there must be two conditions for a body to be in equilibrium. Okay? So the two conditions, number one must be that the sum of all forces actually that should be the algebraic sum, okay? And the second one, the algebraic sum of all moments must also equal 0, okay? So you're looking at this rooster on this plank. Now this plank is stationary, the rooster is stationary, so this whole thing must be in equilibrium. Okay, if we look at the first rule, okay, that up and down, you must be in equilibrium. So the forces going upwards at A and B must be balanced by all forces going down. Now there's two forces going down. Label those FA, FB. This force here in the middle, that's the weight of the plank. Okay. This one here, there's a weight from the rooster, and we'll call that weight rooster. Give that rooster a distance. Let's make this plank maybe 4 meters long. Okay. So halfway along is your weight. Okay, if it's a uniform plank. Okay, so it actually does tell me that it's a uniform plank. Oh, sorry, it's 10 meters long. I should really read the question, shouldn't I? So it's 10 meters long, so that means that must be 5 meters. Now, that's 5 meters. A rooster man of mass 80 kg stands on the plank 3 meters from one end, so that's 3 meters, okay? Now, how do we go about answering this question? First step, let's look at the first rule for equilibrium, and that is that all forces down must be equal to all forces up, okay? The algebraic sum of all forces must add to 0. So all forces up, FA plus FB, must be equal to WR plus WP. Now, let's taking gravity as 10. I do actually know what WR and WP are. I mean, WR is the 80 kg mass of the rooster multiplied by 10, so it's 800, and WP of the plank is 500. But I don't know FA and FB yet. Okay, so we need to go a bit further into this. So so this is rule 1. How about rule number 2 to do with moments? So with the moments part, so there's a different color. So number 2, so this is moments. All anti-clockwise moments equals clockwise moments. Now we need a pivot. We always need a pivot for this. So let's take this point there, okay, as a pivot. Now that means the force B, this force here, is trying to make the plank rotate this way, and these two forces, WR and WP, are trying to make it rotate that way, around this pivot, okay, around that pivot. But it's in equilibrium, so that means the moment going this way, okay, is equal to the moment going that way. So, how do we calculate those moments? Now, let's have a look at it. So what is the anti-clockwise? The one at the top here, that one is anti-clockwise. It's trying to make it rotate anti-clockwise around our pivot. Can't call that anymore, okay? So what's the formula for that? Well, it's going to be FB multiplied by the distance from the pivot. So how far is that from the pivot? Well, if the whole plank's 10 meters long and we lose half a meter to the pivot here, okay, so it's half a meter there, and it's half a meter there, so it's 9 meters from the pivot. Now, if I want to look at the other side, the clockwise moments, that's created by the two weights, and so one of the weights, the weight of the rooster is 800, okay, and I'm going to multiply that by the distance of the rooster from the pivot, which is not 3, because that goes right to the edge. The distance from the pivot is actually 2.5. Now I'm going to add that to the moment created by the weight of the plank. Now the plank is, what, 50 kgs? 50 kgs, so that's 500 multiplied by the distance of the weight of the plank, the center of gravity, from the pivot, so that is 4.5 meters. Okay, so we can do this is calculate all that out and solve for FB. So let's put all this in. Okay, you get around about 472 newtons. Now, the good thing here is we can look back at this first equation up here. We have now got FB, we've now got WR, we've got WP, so we can actually solve for, we can now solve for FA. So FA will be equal to WR plus WP minus FB. Okay, so putting in those values, so it's 800 plus 500 minus 472. Gives you around about 828 newtons. Okay, my rounding is not really the best. I should really say 470 and 830 because I've only been giving you 2 sig figs in the question, but you can go to the same number of sig figs or one more generally. And that makes sense. The greatest force is FA, okay, that's 800 odd, and that's because that rooster man is closest to that end. Example 2, a ladder on rough ground 10 meters long and mass 40 kg leans on a smooth wall. Okay, so let's draw. So here's a wall. It's not a ladder, it's a wall. Okay. Here's my ladder leaning against that wall. Better draw a ground. There's the ground. Now, the ladder base is 6 meters from the wall. Okay, it's 10 meter long plank, 6 meters from the wall. Calculate the friction F between the ladder and the ground. Okay, let's think about some things first. Okay, there's a weight there of the plank. Okay, what else must there be? Well, if you've got to think there's a weight going straight down, there must also be a reaction force from the ground. Okay, otherwise the plank will just fall through the ground. Okay, so there's a reaction force, and it opposes the weight. It's actually the same size. Now, must be a couple other forces maybe. There will be a force out from the wall, otherwise let's call this wall force. I don't know where I came up with that, wall force. And then there must be, balancing out that wall force, a force back in the other direction, and we'll call that one the frictional force. Okay, all you got to do here is similar to the last question. This thing is in equilibrium, so you just need to choose a pivot point. So where will that pivot point be? That pivot point could be anywhere. But what you do is you choose one that will get rid of a force. And I'm going to get rid of that wall force because I don't actually know the size of it. But I do know the size of the weight force, the reaction force, and I'm trying to find the frictional force. So let's put in some values. This thing is 10 meters long. Okay, and we've got a gap of 6 meters that way. So let's work this thing out. What we need to do here is you need to be aware of force multiplied by perpendicular distance. So if we're looking at this pivot at the top here, this weight force has its line of action down there. The perpendicular distance is actually there. Okay, that is the perpendicular distance. So you actually need to calculate what that is. Handily, if you're looking at this weight force being in the center of that line there, then you could probably say it's in the center of the value at the bottom. So, very important that you work that out and then go from there. So, what you need to do is do the weight force multiplied by the perpendicular distance. Okay, so that's going to be that one. So that's that one there. Okay, this is trying to make the thing go in a clockwise motion. What else is trying to make it go clockwise? The frictional force. How far is that from the pivot in the perpendicular direction? Well, that's this distance there. Okay, that's the perpendicular distance there for the frictional force. So we're going to add on the frictional force times the perpendicular distance of that frictional force. And that must be equal to whatever's going the other way. And in this case, it is the reaction force, and that's going to be multiplied by the distance the reaction force is from the pivot, and it's 6 meters. Okay, so I'll leave that for you to solve, okay, and answer in the questions below this video, okay. And so you actually got to be careful with those perpendicular distances. How can you find some more information? Well, it's a 90-degree triangle. Just use Pythagoras to find this side here, and this one here. This distance here, you can just use some logic. Okay, the next thing we'll look at is a couple, but we'll look at that in the next video.